Hi, everyone. Thanks for joining us. In this session, we'll talk about Sumo Logic's contributions to open source projects. Sumo has made a serious commitment to OpenTelemetry, OpenSLO, and open core solutions. We also discuss data collection and how open source tooling such as Kubernetes, Prometheus, Fluentbit, and Fluentd are used in our products. Sumo Logic collects logs, metrics, and traces and event data, and then uses machine-based parsing utilities to provide you with machine intelligence on your DevOps environments. A little about me. I'm the technical advocate at Sumo Logic. So I have more than 11 years of domain experience and expertise as an engineer, product manager, and product marketing manager for developer tools. Some of my hobbies include things like gardening, reading, playing with Marilu, my dog, Milu, and working on side projects. Some past projects include things like running nodes on the Lightning Network, writing smart contracts, running game servers, building dev kits, sewing, and woodworking. And also, as you will discover, creating really awesome memes. What we have here is basically a history on Sumo Logic loving open source projects. So in addition to being a longtime Silver CNCF member, Sumo Logic has invested a lot of sweat equity into open source projects. Some of our recent announcements include in February of 2022, announcing our Open Analytics private beta, which demonstrates the open nature of Sumo Logic's platform. And in April of 2022, putting out Sumo Logic distro for OpenTelemetry. Sumo Logic established OpenTelemetry as its future standard to collect all machine data, which is really awesome. And then in April of 2022, we also launched the Sensu catalog, which allows for self-service infrastructure monitoring powered by an open marketplace. We also announced in May of 2022 that SLOgen basically became part of the OpenSLO standard. We announced a contribution of SLOgen to the OpenSLO community at SLOconf. To talk a little bit about basically data collection with Sumo and how we kind of use open source projects, I did want to start reviewing a little bit about what we do with collecting log, metric, and event and security data using things like Fluentbit, Fluentd, Prometheus, and Falco. So those are all open source data collectors maintained by the Cloud Native Computing Foundation. We utilize open source tools for collection and data enrichment. And given that they all sort of receive a lot of community support, we typically also have integrations for any type of data that you as a user may want to collect. So as far as enrichment, we funnel everything through a centralized Fluentd pipeline for metadata enrichment. And not only do we tag the container, pod, the node, and the cluster, but we also identify the service and deployment for each entry. Kubernetes is rich with metadata, such as pods, labels, and namespaces. The metadata are descriptors of these Kubernetes identities and how they relate to one another. However, each log, metric, and event doesn't expose all this metadata on its own. The purpose of our enrichment pipeline is to ensure that for every log, metric, and event, you know what container it's from, what pod the container is in, and what pod labels are, as well as what node it's on and the namespace that it's running in. And of course, what cluster it's running on. So with metrics basically serving as that smoke detector and logs enabling us to drill down to the root cause, unifying these data sources around a common metadata language enables us to easily correlate those signals. So we can easily pivot from the metrics data about a cluster to the events data about a cluster, and then to the logs data about an application. All this setup is done with a single Helm chart command. It's as easy as Helm install Sumo Logic. So you can give us an access key and an ID that we then use to create the collector and the sources from Sumo Logic. And the Helm chart will then configure and deploy Fluentbit, Fluentd, Prometheus, and Falco. Then the data all comes over to Sumo. This chart kind of has a little bit about how each piece of the collection pipeline works. Specifically with logs, for log collection, we use Fluentbit daemon set, and then we run that on every node in the Kubernetes cluster. So this essentially gathers the logs and then ships them to Sumo Logic. And then with metric collection, for the metrics, we actually use Prometheus. We integrate with Prometheus, which is sort of the de facto choice for monitoring any Kubernetes cluster. The main strength of Prometheus is that it has an auto discovery that works for pre-instrumented things in Kubernetes, along with any custom instrumentation that you may have implemented in your application. So because of that auto discovery, what's really nice is that when you're in the Explorer view, you get to stay up to date with the live state of your environment. And it learns about new components and updates as the data streams into Sumo Logic. As far as events, we developed a new Fluentd plugin that runs as a deployment. So all events go to the API server. The plugin essentially watches on the API server, and then and as new events are basically detected, those are then shipped over to Sumo. So our stock Kubernetes app includes an integration with Falco, an open source tool that detects anomalous activity and security events. Once that's deployed, Falco uses the kernel module, the user space libraries, and Kubernetes audit events to watch for any security events matching one of the conditions defined in the Falco rule file. Notifications are issued for matching events and collected with Fluentbit, just like with logs. Here, you can basically scan that QR code to see our open source observability data collection in action. If you're at all curious, via a demo with custom charts, where we also demonstrate, if you wanted to do custom charts, how you can potentially do that. So on to our SLO stuff. Why do I need service level objectives? Again, according to the book on database reliability management, services that we design and build must have a set of requirements about their runtime characteristics. This is often referred to as service level agreements. SLAs include remedies, impacts, and much more. So what they focus on in the book is on the term service level objectives, and SLOs are commitments by the architects and operators that guide the design and operations of the system to meet those commitments. What's really awesome about that is, if you're at all into memes, we actually did create a really awesome one meant for those SREs who are having to deal with life without, let's say, clearly defined SLOs and without some kind of incident response tooling. So as you're going to sleep and trying to tell yourself and your brain to shut up now, your brain then tells you, well, what if there's an incident at 3 a.m.? So what Sumo has done with SLOs is that a couple months ago, we were at the Noble 9 SLO Conf event, and we announced the contribution of SLOgen to the OpenSLO standards project. So the purpose of OpenSLO is really to help SREs quantify the reliability of their applications through those service level objectives. And Sumo Logic shared that with the OpenSLO community, as well as our commitment to the project as an emerging standard for expressing SLOs as code. So essentially what this does is it enables reliability management as code. All right, so on to Sensu catalog. So in 2021, Sensu was acquired by Sumo Logic. And while the Sensu team has been busy working on direct integrations of Sensu technologies in Sumo Logic, they were also continuing to develop Sensu as a standalone product, including a milestone release that introduced the Sensu integration catalog. Here is the GitHub page, and if you want to learn more and watch this video, this webinar, all you have to do is sort of scan that QR code. The Sensu catalog is an in-app marketplace that enables self-service infrastructure monitoring with a growing collection of turnkey integrations. So on to self-service infrastructure monitoring, why unified collection and analytics matters. Here we see an example of what could happen if teams are collecting data without full observability. Here we see basically an example of what it's like when essentially the blind are leading the blind. One thinks that, this elephant is a sphere, another thinks that it's a tree trunk, another thinks that it's a rope, etc. As long as they cannot observe what the others can, there is essentially poor data fidelity. This is an analog for the IT ops world, where ideally infrastructure engineers should not need to enact application changes due to sending data to various disparate backends. Once a disparate system becomes much larger, especially in systems where it's a highly federated model, standardization then around telemetry becomes very important. So, for example, what if you wanted distributed tracing data to be analyzed somewhere other than the tracing backend? Or what if your team wants to route logging data to a security analyst in a format other than a flat CLI in the logging backend? People want, histograms, charts, and graphs using machine intelligence to statistically analyze and parse through said data. So this is only possible assuming a unified telemetry standard that is also vendor agnostic. So data protection and privacy, as touched upon in some earlier sort of ideas, we essentially have to work around compliance and data protection, especially when dealing with information that could be personally identifiable. So how does this relate to data collection? So the answer is that it becomes impossible to approximate system-wide health across disparate backends, essentially without a way to unify collection methods. When a very common quote that a lot of people have heard is, the wonderful thing about standards is that there are just so many to choose from Grace Murray Hopper, who's a naval officer and computer pioneer. So if you don't want to store data in the same place as you're running, for example, a video game, you would essentially have data such as, user IP addresses, API keys, and passwords that should have storage in separate places. So there are GDPR and COPPA and FedRAMP requirements that teams need to meet, which can lead to lots of disparate tracing and routing in said backends. In gaming, teams will often be working with personally identifiable information, for example, for children. And applications need to log all of this data relating to these kids in a way that is compliant with COPPA, or the Children's Online Privacy Protection Act. In this use case, there are limits to where telemetry data can be stored, who has access to it, and how long this data can be stored before it has to be deleted. The same essentially happens in social media platforms, streaming services, and a wide variety of other applications. Here we essentially have data collection via telemetry pipelines. So Sumo Logic is committed to transparency around data collection. Here we know that having a vendor-neutral format is important for the data collection processes. Your machine intelligence is only as good as the data that you collect via said telemetry pipelines, right? So here we're going into some definitions. A telemetry pipeline routes data, so logs, metrics, and traces from where it is generated to wherever it needs to go, which is often on those disparate backends. This also intersects with the way in which this routing data is exposed via monitoring. So telemetry pipelines not only filter this data, but then produce enriched metadata that's available to various backends and things like, the Kubernetes container information, the region information, the GeoIP information, and other, logging and trace data. So OpenTelemetry, or OTel, as many people are calling it, is an open standard for collection that is vendor agnostic. So it's essentially any format for trace data that attempts to unify the receivers. It comes from unifying projects like OpenCensus from Google and OpenTracing from the CNCF. OTel captures the traces, the metrics, and the logs and other application telemetry data to any backend of your choice. On the right, you see an example of a telemetry pipeline and its corresponding components. So an extremely basic setup here might be something that has a receiver, a buffer, and an exporter. The receiver takes the data at the start of the telemetry pipeline, and it can be in the form of logs, metrics, traces, whatever form that may be. And then the buffer holds the data for a short period of time until the processor or exporters are ready to then take the data. The buffer is in gray because it usually happens mostly in the processor or exporter. So it's kind of part of the other pieces of this pipeline. Then the processor analyzes or transforms the data from the buffer. And that's where you get, information that is then parsed through and given some amount of an analysis. And then the exporter is at the end of the telemetry pipeline. This is where the data gets exported to its corresponding backend in said pipeline. So it can get extremely complex sometimes, but typically the pattern of receiver, buffer, processor, and exporter exists for basically every type of backend. So here we see an XKCD comic sort of lightheartedly poking fun at the increasing number of standards in an attempt to unify what is available, only to end with an additional competing standard. What we have here is on the left, we see that OpenCensus and OpenTracing projects each originated at Google. Since the projects shared the common goal of data unification, they merged in May of 2019 and went under the CNCF governance. This is now OpenTelemetry, which is backed by major vendors and has an incubating status within the CNCF. Foundation work is usually, it's helping to prevent the problem identified by Grace Hopper and the XKCD comic from emerging in this space. So rather than having a variety of competing standards, we're instead sort of unifying all of them. Open census and open tracing don't need to compete. They're both actually just part of OTel. Why OpenTelemetry matters for Sumo Logic? This standardization allows for like vendor neutral trace formats that can then sort of translate to common span event formats and then be easily utilized in big data tools in order to produce in-depth analysis from data collection via the pipeline that was discussed earlier. In this structure, the OpenTelemetry collector acts as both a receiver and an exporter. OTel allows not only for the format standardization, but allows you to use the same agent to collect logs, metrics, and traces. So basically, in summary, OTel allows you to focus more on the analytics by helping you with unifying the collection process. It's very important to Sumo Logic and to our overall strategy moving forward. We find that it's very important for just the general direction of the company at the moment. Thank you for joining us. Reach out to sales@sumologic.com or start your free trial on the sign up. We're very happy to have had you here. Also, if you're at all interested, try submitting serious contributions to any of these open source projects. Thank you.